Hello everyone, welcome you all for the post-contest discussion of Leetcode Weekly 408. So let's start with the discussion. We will be discussing the questions in the order 1, 2, 3, and 4. And yeah, so let's start with the first question for the day. So the first question name is find if, wait a minute. Yeah, find if digit game can be won. So reading the problem statement, you are given an array of positive integer nums. Alice and Bob are playing the game, and in the game, Alice can choose either all single digit numbers or all double digit numbers from the array nums, and the rest of the numbers are given to Bob. So Alice wins if the sum of her numbers is strictly greater than the sum of Bob's numbers. And you need to return true if Alice can win the game. Otherwise, you need to return false. So what is the problem statement? Let's understand it here. The problem statement reads as that, wait a minute. Yeah. So the problem statement reads as that you are given an array which contains numbers in the range, if you look, the numbers are in the range 1 to 99. Okay. So there are either single digit number or double digit numbers. So you have these numbers, let's suppose 1, 2, 10, 12, 98, 4, 6. You have these numbers. Now you are told that there are two people, Alice and Bob, two most common people to coding, to competitive programming surroundings, isn't it? Yeah. So now these two people, now Alice has the choice. What he can do is he can either choose all the numbers that contains a single digit. That is, if you look for this particular example, what can Alice do? Alice can choose 1, 2, 4, and 6. And or he has the option to choose all the double digit numbers. So he can either choose 10, 12, 98. Okay, so he has these options. Now the question is that whatever number Alice is not choosing is given to Bob. So for example, if Alice chose 1, 2, 4, and 6, then Bob gets 10, 12, 98. And if Alice chooses, opt for 10, 12, and 98, then Bob gets 1, 2, 4, and 6. Okay. The question is that is it possible for Alice to get the sum of his numbers greater than equals to the sum of numbers of Bob? This is the question. So I hope the question is clear. So how we can do this? So it requires a simple iteration over these numbers of the array. So what you need to do is you need to maintain two sums, sum 1 equals to 0 and sum 2 equals to 0. You need to maintain these two sums. Now you know that what Alice is getting is like if he is choosing all the numbers that contains a single digit, so add all the numbers that contain a single digit to sum 1. For example, for this particular example, my sum 1 would be 1 plus 2 plus 4 plus 6, and add all the numbers that contain two digits to sum 2. So my sum 2 would be 10 plus 12 plus 98. Now Alice has two options. He either chooses this one or he chooses this one. Okay. So if he opts to choose this one, what sum he will get? He will get sum 13. And if he opts for this particular sum, then he will get 98 plus 1210 plus 10, 120. So the question is that can either choosing these two sums, can Alice get a sum that is greater than the Bob sum? If you read the statement reads this: return true if Alice can win the game, and Alice wins the game if the sum of her numbers is strictly greater than the sum of Bob's numbers. So whatever he is not choosing, that is given to Bob, isn't it? So what he can do is he can like if the sum 1 is not equals to sum 2. If this is the case, if sum 1 is not equals to sum 2, that is someone is let's suppose anything like over here we got someone as 13 and sum 2 as 120. So he can choose sum 2 and Bob will get this someone. If he is choosing sum 2, the Bob will get someone, right? So if this is the case, in so can I say that Alice wins the game? Similarly, if let's suppose someone was somewhere around 20 and sum 2 was somewhere around 14, let's suppose take 10. So again, in this case also, I can say that since someone is greater than sum 2, Allison can again win the game by taking all the numbers that contains a single digit, isn't it? So when will be the case when Alice would not be able to win the game? Because there are only two possible sums. Because all the numbers are either a single digit number or a double digit number. That's already given in the constraints. So when is the case when Alice can't win the game? Alice can't win the game when the value of sum 1 is equals to sum 2. If this is the case, then Alice can't opt for either of the sums. That is, he can't opt for either of the options of choosing either a single digit number or a double digit number, and he loses the game, isn't it? So when the value of someone is equal to sum 2, in that case, we will return false. Otherwise, we can simply return true. So let's see the code. So just remove this part, it's not needed. We have two sums, sum 1 and wait a minute. Yeah. So we have two sums, sum 1 and sum 2. We iterated over nums. Now to check whether the particular number contains two digit or a one digit, whether a particular number is a two digit or a one digit number, there are multiple ways. What I did is I converted the number to string and simply checked the size of the string. So toString function simply converts this number it to string. Then I check that if the size of the string is 1, in that case, I am adding the value of this number to someone. Else, if the size of the string is 2, I am adding this number to sum 2. So I don't require else if also, because if the size of the number is not 1, it will be definitely 2, isn't it? Now I need to return true when sum 1 is not equals to sum 2. So if someone is not equals to sum 2, I can simply return true in that case. Let me try to submit it. Yeah, it works, isn't it? So yeah, this was the code for this question. I hope all of you got it. It was a simple iteration over all the numbers. Calculate all the numbers containing one digit sum and calculate the sum of all the numbers containing two digits and just simply check if that one digit that two sums are not equal. If they are not equal, so Alice can every time choose the sum with the bigger value and win the game. Else Bob will definitely win the game if two sums are equal. Okay. So yeah, this was the solution for the first problem. Let's jump to the second problem for the day. So now looking for the second problem, many I think would have gone for Steve's algorithm in this, but it's not needed over here. Let me uh, get through the code and through the question once. So the name of the question is find the count of numbers which are not special. So you are given two positive integers L and R. For any number x, all positive divisors of x except x are called the proper divisors of x. Okay. Now, a number is called special if it has exactly two proper divisors. For example, if you think of 4, so 4 is a special number because it has proper divisors 1 and 2. And 6 is not special because it has proper divisors 1, 2, and 3. And we are told that a number is special only and only if it has exactly two proper divisors. So you need to return the count of numbers in the range L to R that are not special. Okay. So let's understand what the question wants to say. So the question, first of all, we need to understand what do we mean by proper divisors. So proper divisor of any number x is a number y that completely divides this x but is lesser than x. For example, if I talk of 6, so what are the divisors of 6? Not proper divisors. If I talk of divisors of 6, so 1 is a divisor of 6, 2 is a divisor of 6, 3 is a divisor of 6, and 6 is also a divisor of 6. Now, out of these 4 divisors, the proper divisors are 1, 2, and 3. Because proper divisors are the divisors that are lesser than that number, that is, they are not the number itself. Now, in the question, they have defined a number, special number, if the number of proper divisors of the number are exactly 2. Okay. So just try to think, what are the numbers that can contain the proper divisors as 2? What are those numbers? If I think of any prime number, let's suppose 37. Does any prime number is a special number? Is any prime number a special number? What are the factors that this prime number contains? Any prime number contains. The factors that prime numbers contain are 1 and the number itself. Now, if you think of number of proper divisors of any prime number, they will be exactly 1, right? Proper number of proper divisors for any prime number, they will be exactly 1. So I can say that prime numbers are not a special numbers. Okay. Now, if I think of any other divisor of any number, let's suppose x. So what I know, if I have I as my divisor for any number x, I will definitely have x by I as well in my divisor. For example, if I talk of 6, so for 6 I have 1 as the divisor. So 6 by 1, that is equals to 6, will also be the divisor of 6. If I tell 2 is the divisor of 6, then 6 by 2, that is equals to 3, is also a divisor of 6, isn't it? So can I say that whatever I do, if I am getting any divisor other than 1, first of all, you need to understand that if I am talking of 2 proper divisors, so out of these 2 proper divisors, one divisor will every time be 1, because 1 divides every number. And the other divisor will be some number between 1 and x, isn't it? X is a number whose proper divisor I am going to find. So 1 is one of the proper divisor, and the other proper divisor will be some number between 1 and x. Now, if there is a number between 1 and x, let's suppose y, that is dividing x, that is x modulo y is equals to 0. So can I say this condition that y by x will also divide y? That is x modulo y, x by y, sorry, x by y will also divide y. X by y will also be equals to 0, because when I say that 2 divides 6, so I also say that 6 by 2, that is equals to 3, will also divide 6, right? So if I want exactly 2 divisors, can I say that these numbers x by y and y should be equal? Because they should not be 2 distinct numbers. If they are 2 distinct numbers, I will get 2 additional proper divisors, and I know already that I already have 1 as my proper divisor. I can't afford to have 2 more proper divisors. So can I say that x by y is equals to y? And from here, can I say that y squared is equals to x, or can I say that y is equals to square root of x? Can I say this? So from here, I get the conclusion that, okay, x, for the number x to be special, the short condition that should be met is that x is a perfect square. This condition should be met. But just try to think. Only via this condition can we say that x is a special number, or some extra conditions are needed. Just try to think. Okay, if I talk of 16, is 16 a special number? I know that 16 is a perfect square. It has divisor 4. But is 16 a is 16 a special number? The answer is no. Because what are the proper divisors of 16? It is 1, 2, 8, 4. Like we have 4 proper divisors, and the need of the question was exactly 2. So what extra thing we are missing? How can we determine that a perfect square is a special number or not? So to determine this, the number should be a perfect square. Just try to imagine this. The number should be the perfect square of a prime number. If this is the case, I can always say that the number is a special number. Why? Because if there is any prime number p, so the square of this number will be p square, and this p square will not contain any other factor than p and 1. P and 1 will the only proper divisors of this p square, because p is a prime number. P does not divide more. Like for example, if I talk of 49, so 49 has factors 1, 7 and 7. Since it was a perfect square of a prime number, it has only two proper divisors. Similarly, if I talk of 9, so 9 again has 1 and 3 as divisors. If I talk of 25, 25 again has 1 and 5 as divisors. And you talk of any number that is a square of a prime number, it will contain exactly two divisors, that is 1 and the prime number p. So I hope you all are on the same page of understanding that a number is a special number if it is a perfect square of a prime number. Once this thing becomes clear, now the question is straightforward. They have told you to find the number of special numbers between L and R, isn't it? And they have given that L and R are of the range of 1e9. This is also something given. Now, what you need to do, you know that whatever special numbers are, you need to count the number of non-special numbers, right? So let's count the number of special numbers, and then we know that total number of numbers are R minus L plus 1. So if number of special numbers are, let's suppose, answer, so we can simply subtract this and get our required answers. Like temp, anything you can take. If number of special numbers are temp, so from the total number of numbers, if you subtract temp, you will get the number of non-special numbers, right? So how to get the number of special numbers between L and R? So you know that all the special numbers between L and R would be a perfect square of some prime numbers, right? Now I know since L and R are of the range of 1e9, so the maximum number whose square will lie in the range of this, can I say that it will be square root of R? Can I say this? The maximum prime number whose square will lie in the range L to R, with R being the bigger number of these two L and R being the bigger number, let's suppose L being 1 and R being 10. So the maximum prime number whose square will lie in the range of L to R is nothing but square root of R. And the minimum prime number whose square will lie in the range of L to R will be square root of L. Can I say this? So just use these conditions. Now I know that since L and R are in the range of 1e9, so their square roots will lie in the range of 1 to square root of 1e9. So what you can do is you can just go to each and every number in this range, just check if this is a prime or not. And if it is a prime, you need to just check that if their square lies in the range of L to R, and if it is, just increment the count of special numbers. That is the simple thing that you need to do. And how you can check that whether a number is a prime number or not, how you can do that? For any number I, how you can check that whether this particular number is a prime number or not? So what you can do, you can simply count the number of divisors for this number. Or you can check that if it is divisible by any of the numbers in the range, like 2 to the number before. If it is divisible by any of the numbers uh, other than the number itself and 1, so you can mark it as non-prime. So it is like a very common method to check that whether a number is a prime or not. Okay, I hope that this thing is already clear to you all, that how you can check that whether a number is a prime or not. And once you have that understanding, so you can use this logic to find out, to check all the numbers in the range square root of L to square root of R, that whether they are prime or not. And if they are prime and their square lies in the range L to R, which will definitely be, because since we are taking the numbers from square root of L to square root of R, And if it is, then simply increment the count of special numbers. And if you are, and in the question they want you to tell the count of non-special numbers. So from the total number of numbers, you can simply subtract the count of special numbers. So yeah, this is the logic for this code. Let's see the code so that things become more clear. So I initialized my temp1 to square root of L and temp2 to square root of R and my answer to 0. So this answer basically stores the total number of special numbers in the range L to R. Okay. So starting my number count from temp1 to I less than equals to temp2 I plus plus. If the square of the numbers don't lie in the range L to R, so I am simply continuing. Otherwise, I am maintaining a flag. Now, if the value of I is 2, so I know that this is always a special number. If the value of I is true, what I know that this is always a special number or not. Just tell. Is it a special number? Wait a minute. Yeah. So if I is 2, we know that this 2 is a prime number, isn't it? So we don't need to check that whether I is prime or not. So we know that whatever number will be formed with I equals to 2, what is the number? Number will be 2 into 2, that is 4. So we know that 4 will be a special number, isn't it? And we know that I into I lies in the range L to R. So we simply incremented the count of special numbers and continued from here. And if the value of I is 1, what we already know is that this 1 is not a prime number because the number that will be formed by the square of this number will be 1 and it will not be a special number. So in that case, we are simply continuing. Else, if I is any other number other than 1 and 2, so we need to check that whether that particular number is prime or not, isn't it? So for that, we maintained one variable flag that is equals to 0. Iterated from j equals to 2 to j into j less than equals to I j plus plus, because we know that for a particular number I, we can generate all its divisors till square root of I, isn't it? So went to all the numbers till square root of I and checked that whether j divides I or not. If it divides, that is I modulo j is equals to 0, simply mark the flag as 1 and break. And if after coming out of this for loop, if the value of flag is 0, that is, if not of flag is true, I simply incremented my answer because I know that I is a prime number and hence I into I will be a special number. So I simply incremented the count of special numbers, and at the end, I am simply returning the total number of numbers minus the count of special numbers to tell me the count of non-special numbers in the range L to R. So this part of code is something that you all need to be familiar with, that this is the common practice for checking the number of divisors for a number or to check that whether a number is prime or not. It basically takes the square root of I times. And this is the logic that we are traversing from square root of L to square root of R and checking for each particular number that whether it is a prime or not. And if it is a prime and its squares lie in the range L to R, so we can definitely say that that is a special number. So yeah, this was the logic and code for this question. I hope it is clear. So let's jump on to the next question. Yeah. So this question was a bit on the tougher side as compared to the normal third question that we get in Leetcodes. So Leetcodes contest. But yeah, it is quite interesting one, and it does not require any concept that is not known to us, but it requires some very good logic. So let's see how we can solve this question. So the name of the question is count the number of substrings with dominant ones. So the question reads as you are given a binary string S. So you need to return the number of substrings with dominant ones. Now, what do they mean by dominant ones? So a string has dominant ones if the number of ones in the string is greater than or equal to the square of the number of zeros in the string. So you need to return all the substrings that contain dominant ones, and by dominant ones they mean that the number of ones in the string is strictly greater than or equal to the square of the number of zeros in the string. Like for example, if I take this particular string as example 0, 0, 00011. So the number of substrings over here is like this is a particular substring, because over here the number of count of ones is 1 and the number of count of zeros is 0. So the square of the number of count of 0 is lesser than or equal to the count of number of 1. Similarly, this particular string is also a dominant string because the number of count of ones are 2 and the count of zeros are 0, and the square of the number of count of 0 is still lesser than the count of ones. Again, this is also a dominant string. Why? Dominant substring because the number of count of the number of count of ones is 2 and the number of count of zeros is 1, and 1 square is lesser than 2. Similarly, this is also a dominant substring, isn't it? Because the number of count of number of count of ones are 2 and the number of count of zeros are also 2. Okay, wait, this is not a dominant substring, sorry. Let me erase this. This is not a dominant substring because the count square of the number of zeros will become 4 and the number of ones that I have is 2, isn't it? So this is not a dominant substring. Okay. Let's look for other dominant substrings. Again, this is a dominant substring. Why? Because the number of count of ones are 1 and the number of counts of zeros are 0. Now, this is also a dominant substring. Why? Because the number of count of ones are 1 and the number of count of zeros are 0. So 1 square is lesser than equal to 1. You are given that you can take equal. The number of ones in the string is greater than or equal to the square of the number of zeros. So this is also now a dominant substring. So if you look to any other substring, you will not get a dominant one. So yeah, I can say that for this particular example, the number of dominant substrings are 5. Okay. So I hope the question is clear. Now, how you can think of this question? How to just, what's the intuition behind this question? So, what you can think is that, okay, I want number of ones to be greater than or equal to square of number of zeros, that is number of 0 multiplied by number of zeros. Okay, this is the condition I require. Then, if I think of any string that, okay, I assume that this is a valid substring, that it is a dominant substring. By valid, I mean that it is a dominant substring. Okay. So can I say that can I find the maximum number of zeros that this string can contain? Can I do something like that? Because I don't have any restrictions in one, right? Ones can be many. At least there should be some value, but ones can be many. But I have restrictions in number of zeros for this to be a valid substring. So if I say that, okay, if the number of zeros, if the length of the string is, let's suppose, 9, if the string length, if the length of the string is, let's suppose, 9, so can I have 1 zeros in it? Can I have 1 zeros in it? Because if I have 1 zeros, I have 8 ones, right? If I have 1 zeros, I have 8 ones. Okay. I can have 1 zero. I can have 0 zeros as well. In that case, I will have 9 ones. Can I have 2 zeros? If that is the case, the number of ones that I will have is 7. And yeah, I can afford this particular case as well. Can I have 3 zeros? Can I have 3 zeros? It seems to me no. I can't have 3 zeros. Because if that is the case, I will have 6 ones. And 3 square will result to 9. And I know that number of ones should be greater than or equal to the square of the number of zeros. So this case is not allowed. So if I say that a number is, if I say that I have a valid string or a dominant string of length n, so I can say that the maximum number of zeros, sorry for the interruption. Yeah. So I can say that the maximum number of zeros that a valid or a dominant string of length n can contain is square root of n. Like in this case, I can see that, okay, 3 is also not allowed, but if you take, let's suppose, mm, if you let's suppose take 15, in that case also, if you look, 3 is something, if you are taking 3 zeros, you will have 12 ones, right? You will have 12 ones. So in that case, 3 squared is 9, and you can afford 3 zeros. So in that case, since I am taking the integer value of the square root, so I can say that at max, the number of zeros that I can have is square root of n. Greater than that, I can't afford to have more zeros in my substring, isn't it? This is something that I already know. So how to use this information? Like, okay, this information is okay that many would be able to just go to this particular thing. But how to use this particular information to solve the question? So the idea was that, okay, I have this string. Let's suppose I want to find the number of valid substrings that end at this particular index. Okay. So what are the restrictions that I have? In what condition I have the restriction? I have the restriction in my count of zeros, right? I have restriction in my count of zeros because the maximum count of zeros that I can afford is square root of the string size, isn't it? This is the maximum I can afford. So can I say that, okay, I am at I, just go to all possible zeros that were at the back. Just go to all possible zeros. Like suppose 0 was over here, 0 was over here, 0 was over here, 0 was over here. Let's suppose we had zeros over here. Now what I tell you is that before occurrence of this first zero, just see how many ones you have, how many strings you can add. Then coming to this next zero, then just before coming to this zero, what are the additional strings that you can take? Similarly, just before coming to this particular zero, what additional strings you can take, and just before coming to this zero, what additional strings that you can take that are ending at I. So all the strings that I am talking for now are ending at I. So I want to know that what are the strings that I can take. So I can easily maintain this thing now, that where are the zeros present? I can maintain one index. I can maintain one vector of int where I store the indexes of all these zeros. And over here, we can use that particular condition that the maximum number of zeros are square root of n. Because once the value once this value exceeds, once you encounter more than square root of n number of zeros, in that case, you can simply exit from the loop. And yeah, this was like the intuition behind this problem. We will discuss it further. So yeah, this was something that you need to use. Let me elaborate it further. Let me explain it once more. So you have a string that is ending at I. Let's suppose you have zeros over here, you have zeros over here. Now tell me the maximum length of the substring that you can form that is ending at I. If this is a zero-based indexing format, assuming it to be a zero-based indexing format, so the maximum length of the substring that you can form that is ending at this particular index I is I plus 1, isn't it? Now, if you get the number, so you know that this is the, so can you tell me the maximum number of zeros that I can accommodate? The maximum number of zeros that I can accommodate is square root of I plus 1. Can I say this? Can I say this? So yeah, this was the case for this question that, okay, before coming to my first zero, I know that before coming to my first zero, I know that assuming that this particular value is 1 for now, I will explain with this particular value as 0 as well. But just assume that this particular value is 1. Okay. So you have 1 over here, you have 1 over here, you have 1 over here. So you know that a 0 occurred over here. Let's take indexes as well. This is index 0, 1, 2, 3, 4, 5, 6, 7. Okay. So you need to you need to check that how many substrings that end at this particular index can be taken, right? This is a thing that you need to check. So you know that you started at 7 because you have this index I, you are iterating over this I. So you know you need to find the number of substrings that are ending at I. So just you have, and you have some vector V that contains all the indices of 0 actually that occurred before. So you have 1, you have this index 4 in this, you have this index 1, and for taking this entire string, I also have -1 pushed over here. Once I explain the code, the significance of this -1 will become more clear. But just for now, you can understand that for taking this entire substring, I have pushed this -1 as well. Okay. Now, when I talk that, okay, I am talking of this particular 0, 0 standing at index 4. So I am talking of all the substrings that are starting after this index 4. I am talking of all the substrings that is starting after this index 4 and is ending at 7. Okay. So how many substrings are there? There is a substring starting at 5, there is a substring starting at 6, and there is a substring starting at 7 that is ending at 7. Okay. So till now, how many zeros I have got? The number of zeros till now that I have got is 0. Because this is the first 0 that I have encountered in this particular example, right? So number of zeros that I got is 0. So I can take all these 3 ones. So in my answer, I will simply increment 3. Okay. Now I just move on to the next 0. That is the 0 that was at index 1. So all the values that are not 0 is actually 1, isn't it? These all are 1s. So I simply move on to the next 0, moving backwards. So it is at index 1. So I want to see all the strings that are starting at index greater than 1 and are ending at 7. But I don't want to see strings this particular strings that are starting at 5, 6, 7, because for them I already incremented my answer, isn't it? So I can maintain some previous index as well. So previous index is, let's suppose, 4 over there. Previous index is 4. So what I know, I have 3 starting points, 2, 3, and 4. And till now, how many ones I have got? I have got one zeros. How many zeros I have got? I have got 1 zeros till this point, isn't it? I am not considering the 0 at index 1. Just keep that in mind. Just don't get confused. I am only considering zeros after index 1 till index 7. So till now, I have 1 0. Now just tell me. If I have 1 0, so what is the minimum number of ones that I should have? If I have 1 0, then what is the minimum number of ones that should I have? The minimum number of ones that I should have is 1, isn't it? This is the minimum number of ones that I should have. Now, these are the 3 possible starting points. So how to decide that these starting points are accurate or not? How can I decide this? I can either start at this, my substring can either start from this, my substring can either start from this, my substring can either start from this as well. So how to decide that whether I can take these starting points or not? So for that, I need to have the number of ones that I have. So how we can find number of ones is pretty easy. If you know that you have the 0 at index 4, okay, and your string is ending at, let's suppose, index 9. And you also know that, okay, let's take that particular example only, that we have an index 0 at index 1, and we are having the string ending at index 9, and we know that we had 1 0 at index 4. So how many ones we have? The number of ones we have that have the starting point greater than this one, that is from 2, and ending at 9. How many number of ones that I have? The number of ones that I have is 9 minus 1. That is the total length of the string minus the number of zeros in this string, isn't it? The total length of the string minus the number of zeros. I have 1 zeros. So it is basically 8 minus 1, which is 7. So I have 7 number of 1. Now, if this 7 number of 1s is greater than the number of zeros I have, So I know that I will get some substrings in this ring. I may get some substrings in this ring. Now, how to decide the number of substrings that I can get? So many of you would argue that, okay, let's suppose I have case like this is index 4, this is index 1, and this is index 6. I am considering the substring ending at 6 from this index 2, 3, and 4. All the substrings that are ending at 6. So many of one you would argue that, okay, I have 4 ones, I have only 1 0. So I can take any of these substrings, the substring starting at 2, the substring starting at 3, or the substring starting at 4. I can take any of these. But my friend, this is not always the case. Why? Let me explain why. So let's suppose you have the string something like this. You have 0 over here, and this is actually your I, and you again have 0 over here, you have 1 over here, you have 1 over here, and you have now 0 over here. And this was your previous index because this was the last 0 that you encountered, and currently you are standing over here. So what you want? You want to check that whether you can take these substrings or not, isn't it? You can take these substrings or not. This is something that you want. So if you count the number of ones, it is 2. And if you count the number of zeros that you have, it is 2. So can you take these values? Can you take these number of ones starting at this particular index? The answer is no. Okay, this was pretty much straightforward. This particular thing got rejected when in that case only that the number of zeros is a number of zeros multiplied by number of zeros is greater than the number of ones. In this thing only it got rejected. But this can also be the case that you have 2 zeros over here, you have 1 over here, you have 1 over here, you have 1 over here, and yeah, and you have 1 over here, and you have a 0 over here. Okay. Now, your previous 0 encountered was this. You are currently standing at this 0, and your I is this. That is, your substring is ending at this particular point, and you want to check that whether you can take these particular substrings or not. So you will just simply count the number of ones from here to here. The number of ones are 4, and the number of zeros are 2. You will say that, okay, 2 squared is greater than 4. So let's take all these possible 3 substrings. But is it allowed? Is it allowed to us that we take all these possible 3 substrings? The substring starting at this particular point, the substring starting at this particular point, and the substring starting at this particular point? The answer is no. We can't take all these strings. The only possible string that we can take is this. The only possible string that we can take is this. And how can we get this value? How can we get this value? It's pretty much simple. You have the number of ones as 2. You have the squares of the number of zeros as 4. You have the number of the count of the number of zeros as 2. And you also have the count of the number of ones as 4. So simply just square the count of the zeros. So the count of zeros will become 4. So how many substrings that you can take in this? The number of substrings that you can take is the number of ones that you have minus the squares of the number of zeros plus 1. And why am I saying this? Because just assume that you will have cases like you will have this thing. You have a string something like this. You encountered this particular 0, and your I is this. You are trying to find all the substrings, valid substrings that are ending at this particular index. So what you will do? You know that these all you have already checked. Okay, these all you have already checked. Now these all you have already checked. These 3 substrings you have already checked. Now the substrings that you need to check is starting at this index or starting at this index, this, or this. So these start points you need to check that are ending at this particular index because we are checking for all substrings between 2 zeros. Okay. So these you need to check. Now, you know that you will have consecutive ones over here, isn't it? But and you know that the number of ones that you have is 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 number of ones and you have 2 number of zeros. So can I say that the minimum starting point should be somewhere, the minimum starting point should be somewhere where the number of ones is equal to the square of the number of zeros? Because I know that in between I am not going to get any zero. The zeros are present over here only. So I need to start from some point where the squares of the number of zeros becomes equal to the number of ones. And that is something that I can get easily because I have the number of ones as 9. I have squares of the number of zeros as 4. So I simply subtract 4 from it. So this value comes to 5. Okay, this value comes to 5. Now, if you look the number of starting points, this is a possible starting point. 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 And this is also a possible starting point. Because even if you start over here, the squares of the number of zeros become equal to the number of ones. Because number of ones are 1, 2, 3, 4. And the squares of the number of zeros is also 4. So to accommodate this case, when the squares of the number of ones, when the squares of the number of zeros become equal to the number of 4, you simply add 1 to it. So I can say that the number of possible starting points is the number of ones minus square of the number of zeros plus 1. These are the possible starting points. Now, there can be the case when this value exceeds, like let's suppose we talk of this case 0, 1, 1, 1, 1, 1, 0. Okay. In this case, if I am standing at this particular 0, so what are the strings that I need to check? If my I is this particular index, what are the strings that I need to check? I need to check this particular substring and I need to check this particular substring, right? In that case, if I simply calculate this value, that number of ones are 5, number of zeros are 1. So I simply calculate 5 minus squares of the number of zeros plus 1, I will get 5. So do I have 5 strings to check? I had only 2 substrings to check, right? I had only 2 substrings to check. So what I will do, I will simply, to my answer, I will simply increment minimum of this particular value, that is number of ones minus squares of number of 0 plus 1, comma, this particular value. So this is something the previous 0 where I got. And currently, if I am, let's suppose this is the previous index and this is the current index. So the number of substrings that I need to check is nothing but previous index minus current index, basically ITX. So these are the substrings that I need to check, and these are the possible number of starting points. So minimum of those will give me that how many starting points I can take between these two zeros, including this particular 0. So if I now summarize the solution, what we actually doing and what was actually the intuition behind this question. So it was that, okay, we have all possible strings. We have all possible strings. And we know that the maximum number of zeros that a particular string can contain, the maximum number of zeros that a particular string can contain, if it is a valid string and it is of length I, is square root of I. From there, we came to know that, okay, if we consider all the strings that are ending at index I and just go to all zeros, just go to all zeros, this is not a zero, and just check that how many strings we can take that are starting between, like if we are standing at this particular 0, so that are starting between the next index from this particular 0 till the first 0 we get. Like for this particular 0, we will check if this is our I, we will check that how many strings we can take that are starting at this particular index or starting at this particular index or starting at this particular index and are ending at this particular index I. And in this process, the maximum number of zeros that we will iterate is square root of I. This is the maximum number of zeros we will iterate. And if this is the case, we can say that our code will run in n square root of n time complexity. Because we are checking for every index I, and for every index I, the maximum zeros that we will traverse at the back is square root of I. And we already have where these zeros stand, so we are simply iterating over that vector. And this was actually the code, this was actually the logic behind this question. That between every zero, just check what are the possible starting points and simply add it to your answer for every substring ending at index I. It may take you at least like 2 times or 3 times to understand the solution, but just try taking examples by your own and try to understand that things will become quite clear. The logic is actually pretty simple. Let me go and run through the code. Okay. So wait a minute. Yeah. Okay. So in our n, we have the size of the string. Then we initialized our count to 0. This count basically stores the answer. And we have a vector 0 index that actually stores the indexes of the zeros that occurs. Now, why we are pushing -1 to our 0 index? This is because what we are doing for every string, if we are coming to a 0, what we are doing, we are checking all the possible starting points from one index after this 0, isn't it? From one index after the 0. And why we are doing this? Because we know that there may be a case that a string do not contain any 0, isn't it? Like if, like suppose string was this. So in that case, in our zeros vector, we will have this particular index at the back, isn't it? So we need to check for these strings as well. These are also valid strings. So we are starting at an index 1 greater than the index that we are standing in the 0 vector. So that's the reason I also pushed -1, because on pushing -1, how it helps me, if I am standing at this particular index I, so once I push -1, once I say that I also have a 0 at -1, so it allows me to check this entire string as well. Like if this was the case, if we have 1 1 0 1 1, if our I is at this particular index, so since I have 0 at this particular position, so this will allow me to check these two substrings. And if I say that I have 0 in -1 index as well, so it will allow me to check these possible substrings. So that's the reason I am also pushing 0, 1 at -1 as well. So in our zeros vector, I am pushing back -1. Now I am iterating over all the possible positions. And if S of I is 0, I am simply pushing this in my 0 index vector. Initializing my m with the size of the 0 index vector, initializing my nums to 0. Nums basically tells you the number of zeros that you got till now. Okay. Initializing my idx to 1. So this idx tells me my current index that I am standing at, and my previous index is -1. Okay. Now I go through all the possible indexes in the 0 vector from back to front, evaluate the number of zeros that I get till now. Because if I am standing at a 0, I am not taking this 0 right now. Right now, what I am doing, I am taking all the substrings to the right of this 0, isn't it? So this 0 will not count to my number of zeros that I have got till now. Till now, I have got number of zeros. So my value becomes the square of the number of zeros that I have got till now. Now, what I know is that if I am looking for all the substrings that are ending at index I, so the maximum maximum length of the substring in that case will be I plus 1, and my value can't exceed I plus 1. If it is exceeding I plus 1, I am simply breaking from this. And this is where my code gets optimized, because in this allows me to go to maximum square root number of zeros. This num will go at max till square root of I. So this where the optimization happens. If this is not the case, now what I am doing is whatever last zero I got at, I am initializing that to previous index, and I am initializing my current index to the current index of the 0. So what I am going to do, I am going to look for all the substrings to the right of this index idx, isn't it? So how many number of ones I have? The number of ones that I have is from string I to from index I to index idx plus 1. The number of ones that I have is I minus idx, that is the total number of characters, minus the number of zeros that I got till now. So these are the number of ones that I have. Now, if the number of ones that I have is greater than the number of zeros that I have, if this is the case, so I know that I will add something to my answer. And what I will add? All the possible starting points from the last 0 to the current 0 is previous index minus idx. These are all the possible number of starting points if I have string something like this. So this was the last 0 I encountered, and this is the current 0 I encountered. And let's suppose this is my I. So all the possible number of starting points are 1, 2, and 3, because I am looking for all the starting points from this current 0 to the last 0 that I have encountered, excluding this current 0. So these are the starting points. These are all the possible starting points. So these are the maximum number of starting points, comma, the starting points that are actually valid. This actually, I explained this in this particular example. Let me go to that. Yeah, in this particular example, that I know that these is also a starting point, this is also a starting point, these all are starting points, but the valid starting points starts at this particular index. From this particular index, these are the valid starting points, right? So to get all the valid starting points from the number of ones, I subtracted the square of the number of zeros and simply added 1 to it. This is something that I already explained. If you can't relate to it as of now, just go back to the video and just see what was the explanation for this. So these are actually all the valid starting points, comma, the all possible number of starting points. The minimum of this will get added to my answer. And since I know that I was standing at a 0, isn't it? I was standing at a 0, so simply increment the count of 0 for the next iteration. And at the end, simply return the count. So this was actually the code for the solution. It may happen that it does not become clear to you in one go. It may require some multiple watching the videos and the practicing by yourself to get understand with this code, because this is something that very much it requires the logic to get understood. Once you understand the logic, then the implementation part becomes clear. But it is important for you to understand what actually we are doing. If you understand that, the things will become clear. So what was the basic idea? The basic idea was, okay, that if we have a string, the maximum number of zeros that I can have in that string is square root of the size of the string. So if I am standing at a particular index and I want to check all the possible valid substrings that end at that particular index, so the maximum number of zeros that I need to traverse back is square root of I if I am standing at index I. So yeah, I just go to each and every 0 and see what are the possible starting points and simply add it to my answer. And at the end, once I am done with all the indexes, that is, I am done with all the substrings that end at all possible indexes. So I simply return my count. So this was the code for this solution, and its time complexity is also n square root of n, because the maximum number of zeros that we will traverse for every index I, that is the maximum number of times this for loop will run, is square root of I, isn't it? Because if the value becomes greater than I plus 1, we are simply breaking over here, isn't it? So the maximum number of zeros will not exceed square root of I. I hope the code is clear. Let's move on to the last question for the day. Give me a minute. So yeah, let's see this question. It was a simpler one as compared to the third one. If you understand one simple part of it, then it's actually something that you have already done many a times. So let's see what the question reads. The name of the question is checked if the rectangle corner is reachable. So you are given two positive integers x and y and a 2D array circles, where circles of I is xi, yi, ri, denoting a circle with center at xi, yi, and radius ri. So there is a rectangle in the coordinate plane with its bottom left corner at the origin and top right corner at the coordinate x, y. So you need to check whether there is a path from the bottom left corner to the top right corner such that the entire path lies inside the rectangle, does not touch or lie inside any circle, and touches the rectangle only at the two corners. So you need to return true if such path exists, else you need to return false. So yeah, the question says many things. Let's visualize it. Give me a minute. Okay. So what is given is that you have been given two coordinates x and y. You have a rectangle whose one diagonal endpoint is at 0, 0, and the other coordinate is at some x, y. So you will have rectangle something like this, isn't it? Okay. Now you have been given many circles. And those circles, for every circle, you are given the index of that particular circle, the center of that particular circle, the coordinate of the centers, x, y, and you are also given the radius. These three things are something that is given to you. Now, they have given you many circles like this. It is not that they have given you only one or two circles. They have the vector of circles given to you. So you have many circles like this. It may be something like this. It may be something like this. There can be many circles. Okay? There can be many circles. Now, what they want you to is, they want you to start a path from here and somehow reach this particular point. Somehow reach this particular point. But in that case, your path should lie entirely inside this rectangle and should not touch any of these circles. Now, whatever diagram I have drawn over here, in looking at that, I can see that no path exists, isn't it? But there may be case something like this. There may be case something like this, that you have a rectangle something like this, you have a circle something like this, and you are getting a path something like this. You can go to this path, right? You can have something like this. So how to see that you don't have one or two circles? Like the possible solutions that I thought during the contest was, let me discuss with you all. I was thinking that, okay, I have a rectangle with me. If I don't want to go till this particular point, so what things should I have? There must be some circle, there must be some circle that is blocking this path. That, okay, I can't cross this particular line, that something is blocking entirely to go till this. Because if this is the case, I have circled something like this, and even if I have some minute space over here and minute space over here, in that case, I can simply go like this. No, I can simply go like this. I can simply go like this. There will be some space to go. So there must be something that is blocking. So what are the blocking conditions that I can have? What are the blocking conditions that I can have? If I have my rectangle something like this, so the blocking condition should be that if I am at this particular point, if I am at this particular point, and there are some circles, something like this, there are some circles that don't give any space between them and blocks this path. In this case, I can't cross, no? I can't cross. Also, if there are case something like this, there is a circle. There are circles something like this. There are circles something like this that entirely blocks this path. Again, I can't cross this. I can't cross the line from here and just touch over here. I can't do this. Similarly, if I have something like this, um, I have something like this that this is the case, that I have some circles something like this that don't give spaces between them and it blocks path like this. So again, I can't cross this boundary. I can't go from here till here. I am not allowed to do something like this. Just now, don't get confused. It was mentioned that you need to go from inside the rectangle only, isn't it? So you can't go. Similarly, if I say you that You have a rectangle something like this, and you have these circles something like this. Let's suppose. Wait a minute. Uh, let's not take from here. Yeah. If you have circles something like this that don't give space between them, and this path is getting blocked. So again, from here, I can't reach this particular point. So what are the restrictions that I have? For this particular rectangle, these lines are the restriction. If I have circles that is forming boundary something like this, that is forming boundary something like this, that is forming boundary something like this, or some circles are forming boundary something like this, in that case, I can't start from this particular point and end at this particular point from within the rectangle, isn't it? Even if multiple of these things, even if one of these things happen, I can't cross the line. So how do I check if these things are happening or not? Now the point comes to that how do I check that these things are happening or not? So before explaining this, what I want you all to do is that everyone should be familiar with the DFS call for a graph. That is, if I give you some starting point, you should know the concept of graphs that, okay, you have nodes like this. So you should be able to do a DFS call. Like starting at this, you are going to this, then you are going to this, then you are going to this, you are going to this. This should something that you all should be familiar with. Once you are familiar with this thing, the DFS calls, now the solution becomes very easy because I am just explaining one case and the other cases are something that you all can do the same way as this is. I am explaining this particular case. If this is the case, if I say you, if I say you that, okay, just assume this line of the rectangle as a node of the graph. Just assume this line of rectangle as a node of the graph. This line also as a node of the graph. Let's name it as node n and let's name it as node n plus 1. Okay. Let's name it as node n and let's name this side of the rectangle as node n plus 1. And all these rectangles as some nodes as well. You have been given n rectangles starting from 0 to index n minus 1. So nodes are 0. Rectangle at index 0 is, let's suppose, node 0. Rectangle at index 1 is node 1. Rectangle at index 2 is node 2 and something like this. Okay. Now, for this particular rectangle, and let's suppose we name these also. This particular side of the rectangle is node n plus 2, and this particular side of the rectangle is node n plus 3. Now, if for this particular rectangle, if I say you that, okay, you can clearly see that, let's suppose this was rectangle 0, rectangle at index 0, so it has node value of 0. Let's suppose it was 1, it was 2, it was 3, it was 4. Let's suppose this was the case. The order does not matter to us. But the things that matter is, I can clearly see that, okay, this particular rectangle 0 is connected to two things. This particular side of the rectangle, this particular circle is connected to two things. This particular side of the rectangle and this particular circle. So can I say that there is an edge between node n and node 0, and there is an edge between 0 and 1? Can I say something like this? Can I imagine something like this? Similarly, I can say that since this 1 is connected to 2 as well as 0, so there will be an edge between 1 and 0 and there will be an edge between 1 and 2. So the edge between 1 and 0 is already drawn. So we have an edge between 1 and 2. Similarly, we have an edge between 2 and 3 and we have an edge between 3 and 4 and we have an edge between 4 and n plus 1. Once we understand this, so can I say that if I am starting at n, if I am starting my DFS call at n, and somehow in my DFS call I am able to reach n plus 1, so can I say that this particular path is blocked? Can I say this? Just try to imagine. Because what we have done, when we are telling that there is an edge between two rectangles in between, when that particular rectangle don't allow space between them, isn't it? If this was not the case, if let's suppose this was the case, if this was the case, you have the rectangle and something like this, and you had something like this. There is, and there is something like this. In this case, you would not say that it's the rectangle circles are something like this: 1, 2, 3, 4, 5, 6. If the circles are something like this, in this case, if you start a DFS call from n, you would never be able to reach to n plus 1, isn't it? Because you will go to 1, you will go to 2, and from 2 you will have any other rectangles or no rectangles, and you will not be able to reach n plus 1. So from that you can say that, okay, this path is at least not blocked. Okay. And the same thing you can do for these path, this path, and this path as well. So there are two starting points. Node n is one of the starting point, and node n plus 3 is the other starting point. And from starting from n, if you are able to reach to either n plus 1 or n plus 2, this is node n plus 2. From n, if you are able to reach n plus 1 or n plus 2, in that case, I can return false. Similarly, from n plus 3, if you are able to reach n plus 1 or n plus 2, node n plus 1 or node n plus 2, in that case, you can return false. And if this is not the case, you can simply return true. By true, we mean that we can draw a line starting from this particular node that is ending at this particular node and is within the rectangle and is not touching any of the circles. So this was actually the intuition behind this question. And how we were able to reach this, we just identified that, okay, what are the paths that if that is blocked, if that is blocked, if these paths are blocked, I will never be able to reach this I will never be able to draw a line from starting at this particular node to this particular node. I identified this path, and then I identified that, okay, what between these two circles blocks me to get what between these two circles blocks me. So if these two circles either intersect or simply touch them, so I don't have the path between these two circles. I identified something like this. And once I understand this, I simply draw, if this was the case, I simply drew an edge between these two circles. Assuming these two circles as two nodes, I simply drew an edge between them. And once I understand that, so I simply called a DFS from this or this as a starting point and simply see that if I am able to reach this particular point or this particular point or not. If that was the case, I was simply returning false if I was able to reach. If that was not the case, I was simply returning true. So this was the intuition. It actually required a bit of imagination that how actually things are working and a bit of understanding of this as well. And a bit of like a new thing as well for many of you that we are assuming this particular edge of the rectangle as a complete node. Because you can assume this rectangle something like this, no? Like you have this rectangle. You can assume this something like this, the node. This is a node. This is a complete node that has it has very less height, isn't it? You can assume this as the node, complete node. And if these two nodes are somehow connected, in that case, by the circles, if these two nodes are somehow connected by the circles, so you can simply say that, okay, I can't cross this particular boundary. And similarly for this line, and for this line as well. So this was the logic behind this question. Let's see the implementation part, but implementation part is something that you may implement by yourself as well, but the main thing lies in the logic. Implementation is simply what I told in words, just putting them in quotes. Okay. So let's see the implementation part. So you have been given a function can reach corner containing two parameters, x and y, and the vector of circles. So took the size of the circles in variable n, circles vector in with variable n, constructed an adjacency vector of size n plus 4, why n plus 4? Because we have n circles as n nodes and 4 additional sides of rectangles as nodes as well. So in total you have n plus 4 nodes. So constructing an adjacency vector of size n plus 4. Then taking this value n plus 4 in this variable x, I have this variable x1 and y1 defined here. So in x, I am taking n plus 4. And in x1 and y1, I am taking the two possible targets. That is, I know that these are the two possible targets, right? This is one target and this is one target. You have these two starting nodes. From these two starting nodes, if you are reaching to any of these targets, in that case, you can say that you can't form a line, isn't it? So the two target nodes are n plus 1 and n plus 2, and the two starting nodes are n and n plus 3. So just took these target nodes in variable x1 and y1. Now we need to draw an edge between two intersecting circles, right? How we know that the two circles are intersecting or not? Intersecting at 1 or 2 points or not? How do we know that? We can easily calculate that by the Euclidean distance between the centers of the circle. If the Euclidean distance between the centers of the circle is lesser than Euclidean distance, let's suppose this is y. If Euclidean distance is lesser than equals to the sum of radius of the circles, in that case, we can say that these two circles intersect and we can draw an edge between them, isn't it? So just iterated over all the possible pair of circles, that is by using these two loops, and simply checked if the Euclidean distance, that is square root of uh, x1 minus x2 square plus y1 minus y2 square, if that is lesser than equals to the sum of radius of the circle, in that case, I am drawing an edge between these two circles. So these two circles are noted by two nodes I and j. So simply drew an edge between node I and j. So adjacency of j dot pushback I and adjacency of I dot pushback j. Once I am done with this, I know that I also need to draw an edge between the side of the rectangle and the circles as well. So for that, I went to all individual circles, then simply checked that, okay, how do I know that whether this particular circle is intersecting with this particular side or not? So if the x coordinate of this circle is lesser than the radius, if x coordinate of the circle is lesser than equals to radius, in that case, I can say that this particular circle will share an edge between this particular node, that is this particular side of the rectangle, that is node n. So if if circles of I of 0 is lesser than equals to circles of I of 2, in that case, I am simply drawing an edge between I and n, and similarly for all the remaining sides as well. So like this is for I and n plus 1, this is for I and n plus 2, and this is for I and n plus 3. Once you are done with this, once you are done constructing the edges for this graph, so now you know that you have two possible starting points, n and n plus 3, and you simply need to look that you can reach to the target node n plus 1 or n plus 2 or not. If you can reach to either of these nodes n plus 1 and n plus 2 by starting at n or n plus 3, so simply return false, otherwise return true. So this helper function helps us to identify that either starting at n or n plus 3, we can reach to n plus 1 or n plus 2 or not. So this helper function takes two possible starting nodes, that is node 1 and node 2. So first of all, I am starting from node 1 because I am using a simple DFS. So I am starting from node 1. You all can also implement the same via BFS or multi-source BFS as well. So starting from node 1, initializing my visited vector to all 0, I know the size of my visited vector will be x, that is n plus 4. So just passing this DFS function with this node 1 as the starting point, adjacency vector and visit it. If this DFS function returns me true. Now let me see what this DFS function is returning, when it is returning me true. So in this DFS function, I am simply marking this node as visited, going over all its adjacent nodes. If that adjacent node is either x1 or y1, so this x1 and y1 were actually two possible target nodes, isn't it? So if this node is either x1 or y1, I am simply returning true. Else, if that particular node is not visited, I am making a simple DFS call from there. And if that DFS call is returning me true, I am returning true. And if I have not returned true till now, so I know that from this particular path, I can't reach to either x1 or y1. So I am simply returning false. So if this DFS function starting from this particular node, node 1, if it is returning me true, I am simply returning true. Then I am resizing, or that is clearing this visited vector. And again, this node 2 as a starting point, I am making a DFS call. And if it is returning me true, I am returning true again. But if I don't get a true result from either of these starting points, so I can simply return false. That is, either from starting from node 1 or node 2, I can't reach node 3, or I can't reach x1 or y1. In that case, I am simply returning true. That is, I can draw a line starting from one end to the other end of the diagonal. So I hope the code is clear. The code is actually the implementation of the logic that we already discussed, and it completely depends on how you want to implement it, but the logic remains the same. So implementation part was actually not a tougher side of this problem, but a more tougher side was actually identifying that how you can solve this. There can be multiple ways as well, but this was one of the easiest way to solve this question. So yeah, that's all from today's contest discussion. Uh, if I want to review this contest, rating level of this contest, so I would say that third problem was the toughest of all the four. Unlikely, like it's not actually happens every time, but yeah, for today's contest, I can say that third problem was on a more difficult side as compared to the fourth one. And fourth one was actually implementation wise, it was quite easy, but the main thing lies behind the logic. So I hope everyone got it. Thank you.